So picture this. You've got a camera mounted on this vibrating pole, trying to track a speeding car during a negative 40-degree blizzard.
Yeah, usually you'd expect a shaky, dark, just entirely unusable feed from that.
Exactly.
Yeah.
But today's deep dive is into a spec sheet for the Bolin technology EX1030H SDI IP outdoor PTZ camera, and it completely shatters that expectation.
It really does.
We're looking at it's a $7,395 piece of hardware. And our mission today is to decode exactly what makes this professional-grade tool so powerful for broadcasts, live events, and security.
And I mean, understanding how it survives out there really starts with its physical armor. It's built like a tank.
Right.
It has this IP67 weatherproof design. So that's not just, a basic weather seal. It means it's totally protected against dust ingress and can literally take high-pressure water jets.
Oh, wow.
Yeah, and it operates flawlessly anywhere from that negative 40 degrees Celsius all the way up to a blistering plus 60 degrees.
Okay, let's unpack this, though, because I get the value of a rugged PTZ, pan, tilt, zoom camera. But I have to push back on the price point.
Fair enough.
$7,000 is steep. It touts this upright mounting with a 360-degree continuous horizontal rotation and a 180-degree vertical rotation with an auto flip feature.
Yeah, the auto flip is key.
But is that endless mechanical rotation really sophisticated enough? I mean, why not just use multiple cheaper stationary cameras instead of one that spins endlessly?
Well, it really comes down to the mechanics of that auto flip feature, right? And maintaining spatial awareness.
Right.
A fixed array leaves you constantly switching feeds, and that's super jarring during a live broadcast.
Yeah, that makes sense.
Right, so imagine you're tracking a really unpredictable subject, say, a performer running erratically across a massive outdoor stage.
Like at a festival or something.
Exactly. This camera mechanically flips its orientation in a fraction of a second the moment it hits its physical vertical limit.
Wait, really? Just instantly?
Instantly. It rapidly calculates that trajectory to maintain a single, unbreakable line of sight. So the operator never loses the subject in a blind spot.
Okay. Surviving the weather and mechanically tracking the subject, that is impressive. But capturing pristine footage is step one, right?
Sure.
A camera's physical armor is only as good as the internal optics it protects. And pulling a usable image through heavy snow or glaring stadium lights, that requires serious optical prowess.
Oh, absolutely.
The sheet highlights a Sony 12.8 type Exmor-R CMOS sensor and a 30x optical zoom.
Yeah, and the standout metric there, the really crazy part, is the 0.0009 lux minimum illumination.
Yeah, I read that. It's basically like trying to read a book by the glow of a single distant firefly.
That is a great way to put it, yeah. Instead of just passively collecting whatever scarce light hits the lens, that sensor actively processes the image.
Just pulling out the details.
Right, and you connect that low light capability with its YD mode and super image stabilization.
YD is for extreme lighting contrasts, right?
Spot on. But where the engineering gets really aggressive is combining all that with Sony's proprietary autofocus algorithm.
Why does the algorithm matter so much here?
Well, usually when you push a 30x optical zoom, changing that focal length throws off the focal plane.
Right.
And if the camera's vibrating in howling wind, standard autofocus just hunts and blurs.
Because it's trying to calculate depth on a moving target while the lens itself is physically shaking.
Precisely. But this proprietary algorithm allows the lens to simultaneously zoom and focus. It keeps the image pristine even when vibrating in harsh winds.
That is wild. Okay, so capturing the footage is one thing, but integrating that footage into a modern workflow is step two. It has the dual outputs, 3G SDI and up to 1080p 60 IP streaming, plus VSCA and ONN VIF control protocols.
All the standard connectivity and brains you'd expect, yeah.
But here's where it gets really interesting. The sheet mentions Freed protocol support. What exactly is that, and why does it matter?
Freed is a total game changer. It enables integration with virtual production systems.
Like AR and VR.
Exactly. As the camera physically pans, tilts, and zooms out in the elements, the Freed protocol feeds its exact positional data to a rendering engine.
Oh, I see. So it allows this outdoor camera to map its movements perfectly into immersive applications.
Yeah, you could overlay a perfectly stable virtual sponsor logo onto a snowy field, completely synced with the camera's motion.
That is incredible.
Yeah.
So what does this mean for you listening? The next time you're watching a flawless, stable, live sports broadcast during an absolute blizzard, you'll understand the incredible engineering making it possible.
Which really leaves you with an interesting question to ponder. Yeah. Think about it. If cameras like this can automatically track subjects, handle extreme weather, and integrate seamlessly into AR environments using Freed,
Right.
how close are we to live broadcasts that are entirely automated without a single human camera operator in the loop?